chemical formula of a compound is a symbolic representation of its composition. The rules that you have to follow while writing a chemical formula are as follows. The valencies or charges on the ion must balance. When a compound consists of a metal and a non-metal, the name or symbol of the metal is written first. For example, calcium oxide, which is written as CaO, sodium chloride, NaCl, iron sulfide, Fes, copper oxide, CuO, etc., where oxygen, chlorine, sulfur are non-metals and are written on the right, whereas calcium, sodium, iron and copper are metals and are written on the left. In compounds formed with polyatomic ions, the ion is enclosed in a bracket before writing the number to indicate the ratio. In case the number of polyatomic ion is 1, the bracket is not required. For example, NaOH. While writing the chemical formulae for compounds, we write the constituent elements and their valencies as shown on screen. Then, we must cross over the valencies of the combining atoms to get the final formula of the compound. For example, consider hydrogen chloride. The symbols of the elements are hydrogen and Cl. Write down the valencies of each below it and cross over the valencies to get the formula of hydrogen chloride as HCl. Similarly, you can find the formulae of other compounds. We are familiar with the concept of atomic mass. This concept can be extended to calculate molecular masses too. The molecular mass of a substance is the sum of atomic masses of all the atoms in a molecule of the substance. For example, to calculate the relative molecular mass of water, which is H2O, we need to take the atomic mass of hydrogen, which is 1U, oxygen, which is 16U. So the molecular mass of water, which contains 2 atoms of hydrogen and 1 atom of oxygen, is equal to 2 into 1 plus 1 into 16, that is equal to 18U. The formula unit mass of a substance is a sum of the atomic masses of all the atoms in a formula unit of a compound. Formula unit mass is calculated in the same manner as we calculate the molecular mass. The only difference is that we use the word formula unit for those substances whose constituent particles are ions. Now coming to the mole concept, which is a very important and interesting concept. Take an example of the reaction of hydrogen and oxygen to form water. This reaction indicates that 2 molecules of hydrogen combine with 1 molecule of oxygen to form 2 molecules of water, or you can say it in another way. 4U of hydrogen molecules combine with 32U of oxygen molecules to form 36U of water molecules. We can infer from the above equation that the quantity of a substance can be characterized by its mass or the number of molecules, and a chemical reaction equation indicates directly the number of atoms or molecules taking part in the reaction. Therefore, it is more convenient to refer to the quantity of a substance in terms of the number of its molecules or atoms rather than their masses. So a new unit, mole, was introduced. 1 mole of any species, be it atoms, molecules, ions or particles, is that quantity in number having a mass equal to its atomic or molecular mass in grams. The number of particles present in 1 mole of any substance is fixed with a value of 6.022 into 10 raised to 23. This is an experimentally obtained value. This number is called as the famous Avogadro constant or Avogadro number. So, a mole represents 2 things basically. First of all, it represents a definite number of particles. It can be atoms, molecules or ions, which is equal to the value 6.022 into 10 raised to 23. Secondly, it represents a definite mass of a substance equal to the gram atomic mass of an element or the gram molecular mass of a compound. Gram atomic mass of an element is its atomic mass expressed in grams. For example, gram atomic mass of oxygen equals O2, that is 16 into 2, which is 32 grams. Whereas gram molecular mass of a compound is its molecular mass expressed in grams. For example, take water again, and the value of that is going to be 1 into 2 plus 16, which is equal to 18 grams. Now let's have a look at the relationship between number of moles, which is N, mass small m, molar mass, which is represented as capital M. The number of moles, which is given as N, is equal to m by m. That is mass by molecular mass. Also, number of moles N is equal to the number of atoms or molecules divided by the Avogadro number. So let's do a problem now based on mole concept. Here's the problem. Calculate the number of moles for the following. The first subpart of the question is 52 grams of helium. Here you have to find the mole from the mass. The second part of the question is 12.044 into 10 raised to 23 number of helium atoms. Here you got to find out the mole from number of particles. So how can we do this? Let's see. Take the first question. As per the equation, number of moles is mass by molecular mass, right? That is, the number of moles is small m by capital M. In the given question, mass is 52 gram and the molecular mass of helium is 4. Therefore, the number of moles in this case will be 52 by 4, which is equal to 13 moles. Wasn't that simple? So let's now try the second part of the question. We had also discussed that the number of moles equals given number of particles divided by Avogadro number. Here, the given number of particles is 12.044 into 10 raised to 23 and the Avogadro number, as we know, it is 6.022 into 10 raised to 23. So applying this in the equation, we get the answer for the number of moles as how much? 2. That is 12.044 into 10 raised to 23 divided by the Avogadro number, which is 6.022 into 10 raised to 23. That again was a simple one, right? So now let's summarize this section. For writing the chemical formulae, the step number 1 is to write down the symbols of the elements or ions in such a way that the symbol of the metal or the positive ion is on the left side and the symbol of the non-metal or the negative ion is on the right side. Step number 2, write the valencies of the elements or ions below them. Step number 3, you just have to cross over the valencies of the combining ions. And step number 4, polyatomic ions should be enclosed in brackets before writing the formula. The molecular mass or formula unit mass of a substance is the sum of the atomic masses of all the atoms in a molecule of the substance. And the only difference between the two is that we use the word formula unit for those substances whose constituent particles are ions. And finally, a mole of a substance is that amount of the substance which contains the same number of particles, be it atoms, molecules or ions, that are present in 12 gram of carbon 12 atom.